Okay, so let's start then. So first of all, I want to show you a couple of problems on how to use the formula from the definition, the one that we didn't really use. Because as I told you, the general formula that we used in class, that is, you can find the derivative with that general formula and then just plug in the value, whichever you need, and just find, the equation of tangent line or whatever you need, or the derivative at specific point. So that's why I prefer using the general formula, but we still have those formulas. So let me mark this one as formula number one. And formula number two is this one, f prime of a equals to limit as h approaches 0 of f of a plus h minus f of a over h. Okay, so we have these two formulas that we didn't get the chance to use, but let me show you a couple of examples where we can use them. Example one. So let's say we have f of x equals to 4 over x squared. So I want to find the equation of the tangent line at x equals to -1. Okay, so now if we use the first equation, right? I mean, the first formula by formula one, we have f prime of a equals to, so we will be looking at f prime of -1, right? So we would have limit as x approaches -1 of 4 over x squared minus 4 over -1 squared divided by x minus -1, right? So we'll just, in this formula, we'll plug in f of x, f of a, right? And then x minus a, that would be x minus -1. So in this case, we would have limit as x approaches -1 of 4x squared minus, so this -1 squared becomes just 1, so we have -4, and we divide it by x plus 1. Now we multiply top and bottom by this x squared, right? So that we can get rid of the fraction in the numerator. So we would have then limit as x approaches -1 of 4 minus 4x squared over x squared x plus 1, right? And now what we can do is we can factor out 4 in the numerator. We have limit as x approaches -1, 4, 1 minus x squared. And we also can see that 1 minus x squared can also be factored out as a difference of squares. So let me just copy the denominator. We have limit as x approaches -1 of 4, 1 minus x, 1 plus x divided by x squared, x plus 1, right? And now we can cancel x plus 1, and we'll get limit as x approaches -1 of 4, 1 minus x divided by x squared. And then now just plug in the -1. We have 4, 1 minus -1 divided by -1 squared, which gives us 4 times 2, that's 8. Okay, so the derivative of x 4 over x squared at x equals to -1 is 8. So that is helpful. It's just one step. That's our slope, right? Slope of the tangent line. So we remember that the equation of the line is y minus f of a equals to f prime of a times x minus a, right? So this is just the regular equation of a line, and we can use it to find the equation of our tangent line, right? So we have x value, we have slopes. So the only thing that's left to do is to find y value, and we have everything that we need for the equation of a line. So just like a side note, f of -1 is, so we plug in -1 into our original function, 4 over -1 squared. That would make it just 4, right? So we can plug 4 into f of a, then f prime of a, that's 8, and a is -1. So we have everything. So y minus 4 equals to 8 x minus -1. So we have y equals to 8x plus 8 plus 4, which is 8x plus 12. So this is the equation of a tangent line that goes through x equals to -1. Okay? And that's essentially the solution to this kind of problem. Now, if we want to see how to use the second, what's it called? The second formula, let's do another example. So example 2. F of x equals to, let's say, 1 over 2x plus 1. And we want to find the, again, the tangent line, the equation of the tangent line at x equals 0. So I have a point, 0 comma 1, but you can find this one easily if you just plug in 0 into the equation, right? So f prime of a, again, we will be using that formula, f of a plus h minus f of a divided by h as h goes to 0. So the only difference between this formula and the general formula f prime of x equals to, limit of x plus h minus f of x over h, and h goes to 0. The only difference between these two formulas is that first formula, by first formula, we are evaluating the derivative at specific point, okay? In the second version of this formula, we have x instead of a everywhere, right? So this is more general form. So this is at any point. Here at some specific point, and the second formula is in general at any point. And then after you find your f prime of x, you can plug in any value into your x and find the value of the derivative or the slope of the tangent line at any specific point. Here, you just do that for just one specific point, right? Here in general. Okay. So what we have here is 1 over 2x plus 1. So let's just plug it in. So we have f prime of 0 equals to limit as h goes to 0 of 1 over 2, 0 plus h plus 1. Let me extend that a bit. Then minus 1 over 2 times 0 plus 1 over h. And here we have limit as h goes to 0 of 1 over 2h plus 1 minus 1 over h, right? Because this one is 0, this one is 0, so we have 2h and plus 1. Okay, so now we can just simplify that, and we get, okay, we have limit as h approaches 0 of 1 minus 2h plus 1. So we will just multiply top and bottom by this denominator in the numerator, right? This 2h plus 1. Let me actually probably write it here. So we multiply by 2h plus 1, top and bottom. And we get 1 minus 2h plus 1 over h to h plus 1. Now, okay, let me just open the parentheses first. So limit as h approaches 0, we have 1 minus 2h minus 1 over h to h plus 1. Okay, so ones are gone, then this h is also gone, and we have limit as h approaches 0 of negative 2 over 2h plus 1. So when we plug in 0 into our h, we get negative 2 over 1, which is just negative 2. Okay, so in this case, you see the answer. If you're using this formula, your answer will be just some number, some actual value. If you use this formula, you would have an expression in terms of x, so something with x. Okay, that's the only difference. So, and then after that, after you get your expression in that x, you can plug in, let's say 0, and you will get the answer of negative 2. Or you can plug in another value and to find the slope at any other point. So that's the only kind of difference. So now y minus f of a equals to f prime of a, x minus a, right? This is negative 2, this is 0, this one is 1, right? Yeah. Okay. So we have y minus 1 equals to negative 2, x minus 0. So we have y equals to negative 2, x plus 1. So this is, again, this is the equation of tangent line that goes through 0, comma 1. Okay. Now, let me go over several examples on how to use the power rule, product rule, quotient rule, and some of the um, trick problems. I will not go over everything that you have in your homework because we also have, I will need to tell you about e to the x, the derivative of e to the x. So I will not go over the problems that we didn't cover in class. So today I'll just go over the problems that we had some practice in class. So we can have more of those examples. So let me start with the easy example. H of t is t squared over 2 plus 1. Okay, so in this case, in every single problem, I will be looking for the derivative. Okay, so now for all the problems that are going after that, we will be just, the task will be just to find the derivative of whatever variable we have. So we have h of t, find h prime of t, right? So as you can see, we have here a fraction, but that's the same thing as saying 1 over 2 t squared plus 1, right? So that t is, we can just use the power rule, right? There is no need to use the quotient rule or anything because we don't have t in the denominator. If we had, then probably we'll need to either simplify the expression or use the quotient rule. In this case, this 1 over 2 is just the coefficient, and we have t squared, so we can use just the power rule. So we have 2t over 2 plus 1. So now we can simplify. We have sorry, not plus 1. We don't have plus 1 anymore. So this guy will become 0, right? Because the derivative of a constant is 0. The derivative of t squared, we take 2 in front and reduce the power. So this is how we get, so we had 2 here, we bring it down. So we have 2t, and then 2 minus 1 will be just 1 here. So we have 2t, and this over 2, that's from this coefficient. So these two can be canceled, and we have just t. Okay, so that's it for this example. Next example, and if you have any questions, feel free to stop me at any time. Okay, so next example is f
Excuse
of
me, Professor.
yes.
So what would be the question like they ask you for you to find They would just say find the derivative of this equation.
Yeah, so if a problem is like this, I will ask either, yes, find the derivative of this function, and that's it. You might have a question where I ask you to find, like, let's say I give you the problem and I say find the equation of a tangent line that goes through a point, let's say 0 comma 1, or that goes through x equals to 0 or something like that. So you might have an example like this on the exam, or problem like this on the exam. So yeah, basically the only two steps that you kind of need to do, you need to remember that the equation of a line is y minus y1 equals to m times x minus x1, right? Which in calculus, um, we will be using this type, right? So y minus f of a equals to f prime of a times x minus a. And this f prime of a you can find either by using this formula, right? The first formula, the second formula, or we have the general formula, which is, let me write that. It's the same thing as the second formula, but instead of a, we have everywhere uh, x, right? H goes to 0, f of x minus a, sorry, x minus h plus h minus f of x divided by h, this one. So you can use either of these three formulas, whichever you want. This one, again, is more general. This is what we're using, what we were using in class, but you can use these two as well. But these two formulas will give you the value of the slope right away. This one will give you the answer in terms of x, where you need to plug in, let's say, this -1 for the first example that we had, or the second example was this 0, and you will get the slope. Or you can just apply the formula 1 or 2 right away, and you get the answer for that. It's your call, whatever you think is easier for you. Okay?
Okay. Thank you,
Yeah.
Professor.
And in most of the cases, you will be asked to find the derivative of a function. Okay, so let's look at the next example. So we have f of v, and we have v to the power of 100 plus 2x to the power of x plus 3x squared. Okay, so here we have v, we have x and x here as our variables, right? But this is the function, the f of v. In this case, we want to find f prime of v, okay? So technically we need to write it like this. Oh, sorry, like this, right? But I want to find the derivative with respect to v. Or if you want, I can write it as df dv, like that. Okay, that means that I'm looking for the derivative with respect to v. So I don't care about x's. So in this case, this term and this term are gonna be just constants in this case, okay? And the only kind of variable that I'm taking the derivative with respect to is gonna be this v. So in this case, I will have, so 100 goes down and we reduce by 1 power for the v. So we have 100 v to the power of 99, right? And then this is a constant, so a derivative of 2 to the power of x with respect to v is going to be 0. And 3x squared, if we take the derivative with respect to v, that's also going to be 0. So this is the end. If, for example, we had a function like this, vx, for example, v100 plus 2x v, for example, plus 3x squared v squared, for example, right? And we want to find the derivative with respect to v, then you are treating this 2x and 3x squared as just coefficients, okay? So you're taking the derivative with respect to v only. So you have 100 v to the power of 99 plus 2x, and now the derivative of v is 1, so we don't write it, right? So plus Now we bring down this 2 to the front, right? So we have then 2 times 3, that's 6x squared v to the, now 2 minus 1, that's going to be the first power, so we just don't write it. And this is what we will have for the derivative with respect to v, okay? We will go over, oh, actually, I'm not sure what if it's calculus 2, where we go over that more, or calculus 3, but where you have partial derivative. But yes, and in this case, just treat the other variables as the constants or the coefficients, okay? And take the derivative with respect to whatever variable you're asked. Okay, next example. We have, let's say f of s is square root of s over 4, right? So we did that before in class. It's the same thing as we were saying 1 over 4 times s to the power of 1 over 2, right? So if we want to find the v prime of s, that's going to be 1 over 4 times 1 over 2. So we bring down this 1 over 2 to the front, and we have 1 over 2s, and then 1 over 2 minus 1, right? We have 1 over 8 s to the power of negative 1 over 2, meaning that we have 1 over 8 s to the power of 1 over 2 in the denominator, and then we know that power 1 over 2, that's the same thing as the square root of s, so this is the final answer that we have. Okay, now if we have an example like this, let's say g of x equals to square root of x times square root of x minus x square root of x. Okay, so in this case, you may want to use the power rule, but then you see, like, you will use the power rule, sorry, not power rule, product rule here, and also inside here you'll also need to use the product rule, so that's kind of like nested product rule. What you can do instead, if it looks, too uh, complicated, right? We have to take the product rule 2 times, and one is inside of the other. Maybe it's a good idea to simplify this expression first, and then, just maybe use the power rule if possible, right? So we just distribute the square root of x, and we have, okay, so square root of x squared, right? So we have just x, and then minus x x times square root of x times square root of x, that's going to be another x, so we have x squared in this case, right? Or if you want, you can write it as x squared of 1 x to the power of 1 1 over 2 times 1 over 2 minus x to the power of 3 over 2, and then just distribute that. You have x, so when we multiply these together, we just add the exponents. So we have 1 over 2 plus 1 over 2, which is just 1, right? Or 2 over 2, which is 1. Okay, and then minus x, and now we just add 1 over 2 plus 3 over 2, which is 4 over 2, which is going to be just 2. So this is how we get our x to the first power minus x squared. You can choose whatever, whatever way you like. Okay, now from here, it's easier to take the derivative, right? It's going to be just 1 minus 2x, and that's it. Instead of just, doing the product rule of this times this, I mean, derivative of this times this, and then plus square root of x times the derivative of this expression, and then also inside of that you have some nested product rule, so that's going to be a bit of a mess, while this way it's more kind of manageable and easier to work with. Same goes for the next example, actually. Let me see. H of x equals to x to the third power minus 6x squared plus 8x over x squared minus 2x. Okay. So what we see here is we can factor out x on the top and on the bottom, actually, just to simplify it. Or if you want, you can just apply the quotient rule right away, but maybe there is an easier way to do that, like not take a lot of derivatives and using the formula. So first let's try to simplify it. So we have x squared minus 6x plus 8 divided by x minus 2 in the denominator. So now these two are gone, and we have, now let's factor this x squared minus 6 plus 8. That's going to be x minus 2, x minus 4 divided by x minus 2. And again, these two are gone, and we have only x minus 4, right? And now it's easier to take the derivative of this function. That's going to be just 1, right? Which is much nicer and more manageable to take the derivative. Okay, next example. Okay, yeah. Y equals to x squared minus 2ax plus a squared over x minus a. Okay, a in this case is, I don't know, any number. Okay, so first of all, let's you can again use the product rule, or we can just simplify it and see if we can use the power rule. So we have x. Remember the formula that we have for this. What is that? A minus b squared equals to a squared minus 2ab plus b squared, right? So it looks exactly the same, just with different numbers, right? Or values. So it's the same thing. So we have x minus a squared, right? Divided by x minus a. So we can cancel the square in the top and this denominator. So we have x minus a. And now it's easier to take the derivative, right? Derivative of this function is going to be just 1, because derivative of x is 1 and derivative of a constant is 0. So we have 1 plus 0, which is just 1. Okay, now another example is more from physics. So we have S of r equals to 4 pi r squared, or maybe even, yeah, we can use something in math. So we need to find the S prime of r. So 4 pi, this is just a coefficient, right? So what we are taking the derivative of with respect to r, right? So we have then, so we need to bring down this 2. So we have 4 times 2, that's 8 pi, and r now will be with the 1 power less than 2, which is just 1. So this is our answer for this problem. Now, next example.
Professor,
Yes.
for that last problem, is it that basically all the work we would show on the exam?
For this one,
Yeah.
it's unlikely that I'll give you a problem that's easy like this. But
Oh,
yes, this is the essentially that's the whole work that you need to show.
okay. Thank you.
In case if if you see this problem on the exam, this is the whole work that you need to show, nothing more. Okay, so we have f of x equals to, let's say, x over x plus 1. So in this case, you might want to think that you can do x times x plus 1 to the power of -1, but now you don't really know the chain rule yet, so we will not use this form. Like on Monday, once we cover the chain rule, you will be able to do this problem using the chain rule, but for now we will just use the quotient rule. Okay, so we have f prime of x is, so remember that we have let's say f is equal to u times v, then f prime is equal to u prime v minus u v prime over, oh, sorry, not like this, u over v. Yes, we're using the quotient rule, over v squared, right? And the product rule would be if we have f equals to u times v, f prime would be u times v plus uv prime, okay? All right, so now we will be using the quotient rule. So we have the derivative of the numerator is just 1, right? Times the denominator, x plus 1. Now minus, numerator times the derivative of the denominator. So numerator times the derivative of the denominator is going to be, so we have x plus 1, so x becomes 1, 1 becomes 0, so we have just 1 here, right? And we divide by the square of the denominator, x plus 1 squared. Okay, now let's simplify it, and we have x plus 1 minus x over x plus 1 squared. So these two are gone, and we have 1 over x plus 1 squared. And this is the end of the problem. Next problem. So we have f of x equals to 2e minus 1 over 2x plus 1. Okay, e, that's just a constant, right? We know the value of that. It's 2 point something, 7 something something, right? So we are treating this 2e as a constant and -1 also as a constant. So we see that the whole numerator is a constant, right? In this case. So if we apply the quotient rule, we need to multiply the derivative of the numerator times the denominator. And we see that in the numerator we have a constant, so derivative of that would be just 0. So we have 0 times 2x plus 1. Now minus, now we do the other way around. Numerator times the derivative of the denominator, right? So we have 2e minus 1 times the derivative of the denominator. We have here 2x, that becomes just 2, and then 1 is gone, right? So we have times 2 divided by the square of the denominator. So we have 2x minus plus 1 squared. Now let's just simplify this expression. This is gone because we multiplied by 0. Now this 2, we can we can distribute that. We have -4e plus 2 over the denominator is 2x plus 1 squared. And you can leave it like that. Or you can leave it in as a -2e plus 1. That doesn't really matter if you want, like the numerator, I mean. Okay, next example would be, so let's say we have f of x equals to x squared cube root times cube root of x. So now you have two options. Again, you can simplify it and use the power rule, or you can just leave it as this and use the product rule. So let's first use the product rule, and then we'll check if the power rule gives us the same answer. So for the product rule, we have derivative of the first function times second function, right? So we have 2x times cube root of x. Now, plus, when we have a product rule, we, instead of minus, right, we use a plus here. So plus first function times the derivative of the second function. So we would have x squared times, so now this x, cube root of x, that's the same thing as x over x to the power of 1 over 3. So we have here 1 over 3, x to the power of 1 over 3 minus 1, that's going to be -2 over 3, right? So now let's simplify it. We have 2x cube root of x plus 1 over 3 x to the So we have the second power and negative 2 over 3. That's going to be 4 over 3, right? And we have 2x cube root of x plus 1 over 3. X to the power of 4 over 3. That's the same thing as x cube root of x, right? And we have, so now these are like terms, right? So we can combine them. So we have 2 plus 1 over 3. That's going to be 7 over 3. X cube root of x. Or you can write it 7 over 3. X to the power of 4 over 3. Doesn't really matter. The same thing. Now, what if we...
Isn't it a negative 4/3, Professor?
Why is that? Let me see. So we have here 2 minus 2 over 3. That's going to be
Oh, you're right.
x over 3 minus 2 over 3. That's positive 4 over 3. Yes?
Yeah, you're right.
Okay, wonderful. All right. So, okay. So now what if we were to simplify this expression first and then use a power rule? So let me go back. F of x then equals to, so we have x squared times x to the power of 1 over 3. So 2 plus 1 over 3 is going to be x to the power of 7 over 3, right? So we would have, so now we can take the derivative of this function just using the power rule. We have 7 over 3 x to the power of 4 over 3. So in this case, you see it's much faster, I would say. So you just need to simplify your original equation and just take the derivative and everything is nice and beautiful. While in the product rule, this is these are all the steps that we needed to take. And you see, we can even make some mistakes just calculating all those powers and everything. So choose the easiest way for you to solve. Unless I specifically say on the exam, use the product rule or something else, or power rule. So follow the instructions. If I ask you to solve a problem using specific way, but you know that you can solve it any other way, please use the instructions and solve the problem the way that I want you to solve. Okay. Let's see another example. Okay. All right, this one is nice. Okay, so sometimes if you have something like this, x plus 1, x plus 2, to x plus 3, right? We're not really sure what to do in this case, so don't get scared. You just take the derivative of like one by one. Essentially, you use the product rule, just not like one time for each of these terms. So we had, let's say f was u times v, right? And then f prime was u prime times v plus u v prime. Well, in this case, if you have another, let's say r, then you would just need to add this. So first we take the derivative of the first term, then u v prime r plus u v r prime. So you take the derivative of in the first term of the first a factor, in the second term of the second factor, right? And then the third term of your third factor. Or just if it, you know, if it's hard, then just distribute and use the power rule, also works fine. So if we use this expression and find, I ask you to find f prime of x, you will first, the derivative of the first portion is, so x plus 1, the derivative would be just 1, right? And then you rewrite the rest of it. Then plus, now first and third are, they stay the same, and then you take the derivative of the second one. So x plus 2, the derivative would be again just 1. And then we just copy the first and third one. Plus 3. and then plus, now you take the derivative of the third function. The first two functions stay the same. So we have the derivative of 2x plus 3 is going to be just 2, and then we have x plus 1, x plus 2. All right, and now you can simplify. We have 2x squared plus, so what I'm doing is I'm just distributing all of them together so that I can, well, that would be my last step. And then I'll distribute that. So I have 2x squared plus 7x plus 6. So that's the first one done. Now plus 2x squared plus 5x plus 3. And the last one, we have 2x squared plus, okay, so this is 3 times 2, so 6x plus, that's 2, so 4, plus 4. And now we just combine like terms, and so these two, so we have 6x squared. Now this 5, 7, and 6, so we get 18x, and then 6, 3, and 4, that's gonna be 13. Okay, so this is your derivative. Okay? And again, you can just FOIL all of these three factors and take the derivative. I'm pretty sure you'll get the same answer as this one. Okay, next problem would be like this. F of x equals to 4 3x minus 1 squared. Okay, first of all, we cannot really take the derivative of the denominator in this case if it's in this form, because we cannot apply power rule here. So if we were to take the derivative, right? So 3x, the derivative of 3x is 3, right? This is gone, but then we have this 2 as well, right? So what do we do with that? So when we know the chain rule, that would be easy to do. But right now we don't know the chain rule yet. So probably let's just get rid of this too by foiling this expression. Or so we would have 4 over 9x squared minus 6x plus 1, right? So now we have just a polynomial that we can take the derivative of, and everything is nice. And easy to do, right? So we just apply the quotient rule. So this is 4. Let me just try that because it looks like U. So 4. So the derivative of a numerator times the denominator, right? So derivative of 4 is going to be 0 times 9x squared minus 6x plus 1. Now minus numerator times the derivative of the denominator. So we have 4 times derivative of denominator is going to be, so 2 goes to the front. So we have 9 times 2, that's 18 x. And now we reduce this power by 1. So instead of 2, now we have 1 here. Now minus, again, 6x, the derivative would be just 6. And 1, the derivative would be 0. So we close the parentheses and we have the square of the denominator. So instead of writing it this way, I'll just use the original version of that and just square that. So I have 3x minus 1 squared again. Okay, so now let's simplify. So the first term is gone because we multiply by 0. The second term would be then negative. Okay, so let me actually factor out 6 from the numerator. So we have negative 4 times 6, that's 24. and we have 3x minus 1 divided by 3x minus 1. And here we have 2 times 2, that's going to be 4, so the fourth power. Now you see that we can cancel the term in the numerator, and we can reduce a power here. So the answer would be here negative 24 over 3x minus 1 to the third power. Okay? So this is the way to do this kind of problems. Now, next problem. X squared, square root of x squared plus 8x to the third power plus 16x to the fourth power. Okay. So one way to do it is just, you know, FOIL or factor it, or you can first take these x squared outside of the parentheses, right? Like factor it out, because you see every single term has x squared in it. So we have x squared, then we have 1 plus 8x plus 16x squared equals to x squared. So this one is going to be 1 plus 4x squared. No, not here, outside, squared, like that. So now you see that we can write it as x 1 plus 4x squared like this, right? And that's under square root. And now you can cancel your square and square root, and you get just x 1 plus 4x, okay? And now it's easier. You can distribute x, and you would have x plus 4x squared, and find the derivative of that, which is much easier, right? So we would have 1 minus 8x in this case, right? So this way it's easier to do to find the derivative. So originally, you see, we had this square root of the polynomial, and if you don't know the chain rule yet, that's gonna be hard to do. I mean, we don't really know what to do in this case, right? So the first thing that you might start doing is just simplify the expression inside of the square root, and you see that all of them have x squared, so we just factor that out, and then we see that we have this 1 plus 8x plus 16x squared, and we see that that can be also kind of factored into 1 plus 4x squared, and in this case you can just, you know, get rid of the square and square root. But if again, you can use chain rule after Monday, you will be able to do that. So you will be able to use the chain rule and just take the derivative of this expression without changing anything. It might be a bit, you know, longer than this way, but in case if you don't know what to do, then just, you know, try to simplify it and everything should work. Okay, so that's this expression. Now, let me see what else can we do. Okay, let me do this one.
Professor, for the last one, it'd be plus 8x, right?
Yes, correct. Thank you. Yes. Okay, so let's say we have w squared plus 3w, w negative to the power of -1 minus w to the power of -4. Okay, so again, two ways. First way is to FOIL first and then use the power rule. So if we FOIL it first, we get what? We get w squared times w to the power of -1. So we have w to the power of 2 minus 1, that's just 1, right? And then now I'm looking at these two. So w squared plus, times x to the power of -4. So we have negative w to the power of 2 minus 4, that's -2. So we have 2w -2. Next one is 3w times w to the -1. So w to the first power times w to the -1 power. We have w to the power of 1 minus 1. That's w to the 0th power. So we have plus 3. Okay. And the last one is 3w times w to the -4. So we have here plus 3w1 minus 4, that's -3. So we have -3rd power here. Okay, simplify. Now it's easy to take the derivative, right? So h prime of w is going to be, this one is 1 minus, now we take the negative in front, so we have minus -2 w to the -3rd power, right? Then plus, this 3 is gone because we have the derivative of the constant that's just 0. And we have plus 3 w to the -3, so -3 goes in front, so we have 3 times -3 w to the -4th power. Let's simplify. We get 1 plus 2w to the -3rd power plus, minus 9w to the -4th power, which is 1 plus 2 over w cubed minus 9 to the power of w to the 4th power. Or again, you can leave it like this or write it like this. This is more kind of nicer way. Everything is simplified, but I'm okay with you leaving it like that. Okay, or another way, if we were to, again, use the same w to the 2nd power plus 3w, w -1 minus w to the power of -4. If we were to use the product rule, right, we would have the derivative of the first one times the second factor plus first factor times the derivative of the second factor. So we have h prime of w is 2w plus 3, right? So that's the derivative of the first one. And the second we just rewrite as it is. Now plus, now we rewrite the first one without changes and take the derivative of the second expression, second factor. So w squared plus 3w. Now here we have -1 w to the -2nd power minus -4 to the power w to the -5th power, right? So let's simplify it. We have, okay, so 2w times w to the -1, so this will be gone, right? And we have just 2 minus 2w minus times the -w to the 4th power, that's going to be 2w to the -3rd power. Now I have 3 times w to the -1, so plus 3w -1, and then 3 times -w to the -4th. So that's the first part. Second part now. So we have here, let me just write here as plus because that will confuse me at the end. Okay. So we have w squared minus w to the -2nd power. That's going to be just -1, right? Now we have w squared times 4w to the -5th power. So we have plus 4w to the -3rd power. And now 3w times -w to the -2nd power. It's going to be minus 3w to the -1st power. And then the last one is 3 times 4. That's plus 12w 1 minus 5, that's going to be w to the negative fourth power. Now let's find the common factors or terms. So these are gone. Okay, so now we have this one, which makes it 1. Then we have power of 3, and we also have power of 4 here. Okay, so we have then plus 2w to the power of negative 3 plus 9w to the power of negative 4, which is again the same thing as here, right? So these expressions are the same, which they should be, right? Because this is this, we just use the different ways to find the, what's it called? The derivative. Here we use the power rule, here we use the product rule, and you choose yourself, whichever you like more. Okay. Now, let me do another example where I want to find, so example, f of x equals to x squared minus 1 divided by x squared plus 1. I want to find the second derivative, okay? So first you need to find the first derivative. So you have f prime of x equals to, again, derivative of the numerator is 2x times the denominator x squared plus 1 minus derivative of the denominator times numerator, right? So we would have 2x times x squared minus 1, and we divide it by the square of the denominator, x squared plus 1 squared. Okay, now let's simplify it. Let's distribute the 2x. And we have 2x cubed plus 2x minus 2x cubed plus 2x over x squared plus 1 squared. As we can see that 2x cubed are gone, and we have 4x over x squared plus 1 squared. All right, so this is the expression that we're going to be taking the second derivative of. Now, here's the thing. In the denominator, again, you have a square, right? So we would need to use the chain rule for that. We don't know chain rule yet, so we cannot kind of find the derivative of the denominator yet. But if we factor, or if we FOIL, or whatever it's called, like expand this expression, we have 4x over x to the fourth power plus 2x squared plus 1, right? Now it's a simple polynomial. We know how to find the derivative of this polynomial. So let's find the second derivative of our function. Again, derivative of the numerator times denominator minus numerator times the derivative of the denominator. Okay, so we have 4 times x to the fourth plus 2x squared plus 1 minus 4x. Now derivative of denominator is 4x to the third plus 4x, and 1 is gone. We divide that by, I will use the compressed version of that because there is no need to keep it this way in the denominator. We're not going to do anything with that. So we have x squared plus 1 squared. It was first it was squared, now we square it again, right? By the formula. Now let's simplify that. So we have 4x to the fourth power plus 8x squared minus 4 minus 16x to the fourth power minus 16x, x squared divided by x squared plus 1 to the fourth power. Now we can combine like terms, right? And we get, and then we also, we have negative 12x to the fourth minus 8x squared plus 4 divided by x squared plus 1 to the fourth power. Now we can factor out negative 4, I guess, from here and see what we get. So negative 4. We have 3x to the fourth power plus 2x squared minus 1. And we divide it by, again, x squared plus 1 to the fourth power. Now, let's see if we can factor it out. So we have 3, negative 3, and 2, so we can do 3x squared, fourth power plus 3x squared minus x squared minus 1, right? So these are together. Yeah, okay. So we can do negative 4, 3x squared minus 1 in one parenthesis, and another factor is x squared plus 1, and we divide it by x squared plus 1 to the fourth power. Let me just write that. Okay, and as you can see, we can cancel one of the terms, and we will have negative 4, 3x squared minus 1 over x squared plus 1 to the third power, right? And that will be the end. So this is your second derivative of a function. Again, you can continue on, right? But now it will be getting a bit harder and harder to expand the expression in the denominator without the chain rule. Okay. Are there any questions on this type of problems? Okay. So let's go to several trig problems and I'll let you go. Okay, so example. Just let's start with the easy ones. So 5x squared plus cosine x. Again, remember that I showed you we have sine, positive sign here, cosine positive here, negative sign on the bottom, and negative cosine here on the left side. So remember that derivatives, they go clockwise, right? So the derivative of sine is cosine. The derivative of cosine is negative sine, and so on and so forth. So if you remember this kind of unit circle motion, then you don't technically even have to memorize anything regarding the derivatives of trigonometric functions. And tangent, cotangent, secant, and cosecant, they can be easily derived. It will take some time if you don't remember that, right? But you can easily derive that even on exam. Just on a scratch paper, just derive the derivative and you should be fine. So in this case, we would have y prime is 5x squared becomes 10x, right? And then cosine, as we said, becomes negative sine x. And that is it, right? So this is just an easy example with trigonometric functions in it. Okay, and next example is, let's say we have 1 minus sine x over 1 plus sine x. Okay. So in this case, we will be using the quotient rule, right? Again, derivative of the numerator. So we have negative sine. The derivative of negative sine is negative cosine x times the denominator, 1 plus sine x. Now minus 1 minus sine x from the numerator, and the derivative of denominator is 1 is gone, sine becomes cosine. Okay. And we divide by the square of denominator, plus 1 plus sine x squared. Okay. Now let's just simplify it. We have negative cosine x minus sine x cosine x minus cosine x plus cosine x sine x divided by 1 plus sine x squared. So these are gone. And we have just negative 2 cosine x over 1 plus sine x squared. So you can leave it like that. I don't need you to do anything else with that. Okay? All right. Next example would be sine x cosine x. Okay, I want you to find the first derivative. Again, this is the product rule, right? So first the derivative of the first one times the second one plus first one times the derivative of the second one. So we have sine becomes cosine x times cosine x plus sine x times cosine becomes negative sine, right? So we have cosine squared x minus sine squared x. You can leave it like this, or you can write it as cosine 2x if you remember this identity, okay? All right. Next one would be tangent x plus cotangent x. Now, first thing, remember we already derived that tangent is secant squared x, right? And cotangent, that was negative cosecant squared x. So now we didn't look at the, oh yeah, with this one we're fine. So y prime is, so tangent becomes secant squared x, and cotangent becomes negative cosecant squared x. And you can easily derive it. Just look at the notes from Wednesday, and we derived, I think, both of these, right? Okay. So now what if we have an example like right, secant x times tangent x. Okay. We know what the derivative of tangent, but I just told you what the derivative of the secant, but let's derive that. So what if, so what is d dx of secant x? That's gonna be, so first of all, secant is 1 over cosine x, right? So we will use the quotient rule. So 1 becomes a 0, right? So the derivative of the numerator times the denominator minus numerator times the derivative of the denominator. So derivative of cosine is going to be negative sine x. And then we divide it by the square of the denominator, right? So now this is gone, and we have negative times negative, so that would be sine x over cosine squared x. Now we can separate this cosine into sine x over cosine x times 1 over cosine x, right? And we know that sine over cosine, that's tangent x, and 1 over cosine x, that's secant x, right? So the derivative of secant is tangent secant, tangent x times secant x. The same goes for the cosecant, right? It's gonna be, I believe, negative in this case, negative cotangent times cosecant. But you can derive it yourself exactly the same way. All right, so now we know what the derivative of secant, we know the derivative of tangent, so now we can take the derivative of this expression, secant x times tangent x. So the derivative of the first one times the second, so we have tangent x times secant x times tangent x, right? So that was the derivative of the secant. and tangent just stays as is. And now plus, now we rewrite the first expression, secant x times, now derivative of the tangent is going to be secant squared x, right? So now we just simplified, we get tangent square x, secant x plus secant cubed x. Now you can factor out secant, doesn't really matter if you want. So you can factor out secant x, and we have tangent squared x plus secant squared x. Now we also remember that secant squared is the same thing as 1 over tangent squared x, so you can write it this way, secant x, and then we have 1 plus 2 tangent squared x. If you want, you can write it this way, but I'm totally fine with you leaving it this way. Okay? If you want, you can write it this or this way, doesn't really matter. Okay? And let's look at the last example probably, and then I can leave you, let you go. Okay, x squared times sine x times tangent x. Again, remember, now we have three terms, right? So we take the derivative of the first one, then for the second term, we have the derivative of the second one, and for the third term, we have the derivative of the third factor. So we have first 2x times sine x times tangent x plus, so that's y prime, x squared. Now, derivative of sine is cosine x, tangent x plus, now derivative of tangent. So we have x squared sine x times tangent becomes secant squared x. So you can leave it this way, or you can simplify this cosine times tangent. We know that tangent, that's sine over cosine, right? So they can be canceled. So we have here 2x sine x tangent x plus x squared sine x plus, yeah, if you want, you can also write it, so sine times 1 over cosine squared, right? So one of them goes to tangent, another one goes to secant, right? So you can write it as x squared tangent x secant x, or leave it like that, doesn't really matter. So yeah, all of these ways are fine as long as you take the derivative correct. So that's kind of it. That's all I have for you for now. Do you have any questions? If no, then we can stop here and then we will continue working on Monday and yeah, get more material done. And hopefully that helps.
Thank you, Professor.